Luce, General Manager of RAECO Rents. I'd like to thank all of you for taking the time out of your busy schedules to join us for our webinar on perimeter dust monitoring. Our presenter today is Tom Douglas. During this webinar, he'll cover the following: reasons for perimeter monitoring, considerations for your project, available technologies and instruments. Tom has 15 years experience working in environmental health and safety industries and worked with various instrumentation technologies for 10. Currently is a member of TSI's health and safety team, selling, training, and supporting instruments like the PortaCount, DustTrack, QTrack, and Quest sound and noise instruments. Tom currently lives in Phoenix area with his wife and daughter. Welcome, Tom. Take it away.
Thanks, Matt. Appreciate it. I was talking earlier, it's kind of nice to be on the other side of this. Past life, spent a little time at RAECO and was usually coordinating these things and doing the intro and directing. So it's a little different role here today, but thanks for dialing in. As Matt kind of alluded to, it's a quick agenda introduction. Appreciate the nice intro. Yeah, I have been with TSI for about 6 years now, working with our health and safety group. So that has to do with a lot of our respirator fit testing, a lot of air, dust monitoring, both indoor, outdoor, some of our sound and noise technologies for Quest, and starting to move a little bit more into the low cost sensor world as well. So here's what we're gonna cover, just kind of the basics. Hey, why are we doing some dust monitoring? Reasons for it, beyond, regulation obviously playing a big part. And really what I would spend a lot or more of the time is really considerations for your project. I think to think about, before you start looking at what solution is going to be best for you, laying some of those things out is going to make it easier for you to pick, hey, this is going to be the right solution for us, whether it's collecting data, maintaining instruments. So really try to smooth that process. We'll walk through a little of the available technologies that are out there. There's a lot to choose from. There are more that are jumping into this field. So it's probably, if you do a Google search on different dust monitoring or air monitoring technologies, you probably get flooded with a lot of different information. So try to help sort through that just a little bit. And I've got a couple project examples, just some things that we've done in the past and where some of these technologies have assisted. And then obviously some time for questions and try to guide you the best way we can. So kind of big picture, why we're dust monitoring. Obviously, we're concerned with human health, and for those that are employees, or maybe subcontractors, even the community at large. Really, we're doing a lot of these things because we may be digging up something from the earth that we don't want people breathing in. We use the perimeter monitoring to determine, hey, do we even need to have any kind of dust suppression? Do we need to be sending alerts to the community? And now we can show, hey, are these things that we're doing, do they work or not? And last two, I've got, really related around the community. There's a lot more awareness to air quality, not just because of, wildfires, but, kind of any digging activity as communities are building out areas that, industrial areas or mining areas that may have been in wide open spaces, and that wasn't a concern in the past, may be a concern now. Obviously, if you're doing any kind of construction in urban areas, that's going to be concern to either tenants in the area or just commuters. And the last part's really trying to establish community confidence. I mean, we're doing these things, to promote human health aspect of it, but we also want to show that, hey, we're doing this not because we have to, but because we care about the community that we're in as a business. So these might be some of the different activities that might be happening that you'll have to do some dust monitoring. Construction, obviously, being the big one. Anything where we're digging up dirt is gonna kick up amount of dust. Construction, and it may just be not just digging, but cutting, grinding, any of these activities that may flow onto the street, onto neighbor property, and then demolition. Obviously, something coming down is gonna make a mess. Site remediation, brownfield super funds, kind of put those together because a lot of that is regulatory based. EPA has a lot of strict rules for digging up any areas that have been contaminated over time. So extra caution has to be put in place when doing any kind of digging activity in those areas. Mining's certainly been growing. I'm out in Arizona. We've got a lot of surface mines out here, just out west in general. And I was mentioning before, there's, as there's a lot of population moving out, a lot of people moving to Arizona, moving to Utah, moving to Idaho, moving to places where, these mines have been in more remote places, but populations are moving out those way. And so mines have to be more cognizant of the community around them. Rapid response and environmental cleanup's another one that's kind of been growing. Any kind of environmental spill, structure fires, wildfires have been really big out here on the West Coast as well. Monitoring maybe not just during wildfires, but really having some kind of monitoring system in place if and when they do pop up. But also being able to get information quickly to people is important with some of these rapid response. And sometimes it just comes from community complaints. Could be a factory or process, and there may be a neighborhood nearby, and the neighborhood complains either to the city or local air advisory board or something that, hey, we don't like what's going on here, so may have to set up some monitoring to look at things. Just touching briefly on the regulations. EPA and OSHA obviously are the big regulatory agencies that have some certain regs, and those of you who plan those projects are probably very familiar with them. Then we really dig into it. A lot of different states, counties, even locals will have their own rules. A couple of the ones that are kind of larger, DR10 in New York. I think that combines both dust, and I think they have some VOC requirements as well. And I think it's like once they hit like 150 micrograms for PM10, they have to take some actions. Kind of similar with Rule 1466 in Southern California for monitoring PM10. Theirs is kind of digging if there's a differential of 25 micrograms, then certain actions have to be taken place or work has to stop. So it's important to look at not just the federal regs, but what is local that you may not be thinking about. It's good to have those in place. Oops, going the wrong way there. So moving on to kind of considerations for your project. Kind of got these bunched up into four. First being data considerations, how quickly you need to have information. The actual instrumentation selection itself. Hey, what's going to be the best instrument for the information that we need? But then on the back end, thinking about the maintenance side of it, whether it's equipment you own, whether even you're renting equipment like from RAECO Rents, you still want to consider, hey, how are we going to take care of this, this equipment if something does go down? So something to think about. And then budgeting obviously is an important part. Long-term projects, do that buy versus rent, analysis, but walk through that real quick too. So I like to start with data considerations because that is ultimately what we're doing this monitoring for, is because we need information. How do we need to get the information? Who needs to see it? So really like to start with that. So you want to have like basically a list of, like, hey, how do I want, who needs to see this? How do I want to get it? Do I want to send somebody out into the field and have to collect information, send it to a lab? Wait for results to come back, or even just go out to an instrument, take a reading. Do I need to have information right now? A lot of moving right now towards cloud-based solutions to give you the information right away. How often do you need to see it? That comes into play as well. That's where a lot of those real-time and cloud-based solutions help, because you can see data immediately. Not exactly related to dust, but as far as need of information, some of you may recall that benzene leak outside Houston. I think it was about 3 years ago, like the Deer Park area. But one of the complaints there was that they did have these different monitoring stations, but they were only recording data or reporting data just a few times an hour. I think it was about every 15 minutes or so, and that just wasn't soon enough. They really wanted to have information sooner. So with your project, does that give you enough time to react to an issue, or do you need to know now? Who needs access to your data? If you're a contractor, do you have subs on site that they need information? Does the community need to know? Do you need to set up a system where that information not only flows internally, but also flows to maybe a city website or a county website? Do they need to see that, and how often? It could just be the regulatory agencies. Hey, we just need to do a report for them, once a week or once a month or what have you. So think about that. Obviously, the where to monitor on our site always comes up. Like, where do I need to put monitors at? If I just put one monitor, is that enough? I don't know. Maybe. Typically you're going to see an upsite monitor and or a upwind, downwind monitor on site, so you can have that differential to see, hey, is our activity actually adding to the dust that may already exist in the environment? Maybe there's more. Maybe it's based on, you might have multiple activities on a site, and you need to have monitoring points at each one of those activities because you need to see what's going on at multiple places. So certainly something to think about. Talk about how accurate you need to be. We'll get into a little bit more of that with the instruments themselves. You may just need to have some baseline indicative information, but you may also have to have very, very, accurate. If you're, reporting to EPA, for example, they may want to see that. And even EPA might, they might tell you, yeah, we need to have, federal reference, method technology used. Others might go, you know what, near reference is good enough, or just some indicative, or so it might depend from project to project. And then finally, alerts and actions. If a certain threshold is hit, who needs to be alerted? What do you need to do? It might be as simple as, hey, we hit a certain concentration level, we need to send out a water truck. It could be a certain concentration levels hit, and well, now we got to inform the community, or there's a school nearby, or something else. So think about that, and like how that information is going to be relayed to those parties that are involved. So once you kind of thought about some of those things, we can kind of start moving into, okay, let's find the right instrument for my application. And I ask, do we start with federal reference method? Get that question a lot. People think, hey, I've got to do some, either air or dust monitoring, and I need to have, the federal reference method. There's a nice, EPA has a list of all the different, manufacturers and types on the EPA website. So if you need to use that type of equipment, that is listed there, and that makes that search a little bit easier for you. A lot of times with construction jobs, sometimes near reference is acceptable. If you can find an instrument that correlates well with federal reference method or federal equivalent method, that might be good enough, and that we see that quite a bit out in the field. So good to think about there too. Expected concentration ranges. If you're in an area that's already kind of dusty and arid anyway, there might already be a lot of ambient particulate. And so then if you add that extra activity, like, are you going to max out an instrument, with that digging activity, or with that construction, or any of those other activities? So take a look at that and see where, because instruments can vary. Some can handle very high concentrations very well. Others, really made for, really almost like air, ambient air monitoring, not really made to be put in a really dusty or dirty area. So think about that, because there's the possibility you could miss data if you max out an instrument. You might miss some points that you may need to collect. And this is kind of on the other end, is powering units. There's a lot of different units out there that require you to have a power source. If you don't have access to power, then what do? You need to get in their activity. Obviously, there's solutions with, there's some battery solutions, solar solutions out there. Need to find what's going to work best for you. So kind of want to move on to the, thinking of the maintenance side of the equipment. If you own the equipment, obviously it's yours. Something goes down, it's, you got to do something with it. Considering do these things, can I easily do this in the field? Can I swap a pump? Can I change out a battery? Can I, pull data, whatever it is, can I just do that from the field? Can it be done pretty easily? Or do I need to send instruments back to, a manufacturer or to a distributor? This equipment need to be swapped. This comes up a lot too. Having extra units, does it make sense to have an extra unit or two on site in case something goes down if you're having to monitor all the time? Certainly if you own your own equipment, that's maybe a good idea. With rental, even then with rental, sometimes it's a good idea to have one so you can swap it out. And if one goes down on you, you can send it back to your rental house and go, hey, this guy needs to be swapped, but at least we're up and running. And then they're usually pretty good about getting another unit back to you. And then really think about who is going to be responsible for that, regardless whether it's whether you have a rental house or you're owning your own equipment. You want to have somebody that's ultimately responsible for taking care of that equipment. That's either going to be the one going out and checking on it. Can't just be like, hey, if everyone, it's kind of one of those, if everyone's responsible for it, no one is. So really need to make sure you have somebody assigned to that to watch that stuff. And then, the last is your budget considerations. If you're a contractor, you're working on a bid. Obviously, the cost of the project and the cost of buying instruments may weigh into that. Once you start getting to, and it can vary by project, seen a lot where, if you start getting about 4 or 5 months, might make sense to own some instruments for the length of a project. Short ones might make more sense to rent a unit because you have that, you can, bill it back to the customer, makes perfect sense. So also something to weigh. And then even with the rental houses that you work with, I know RAECO does a pretty good job on the customer service side and getting equipment, something does go down, getting something sent back out relatively quickly. Even same with the, I guess it kind of falls back into the maintaining with owning your equipment. Like, are you going to have people out in the field that can, help you? The, manufacturer, are they going to be able to support what you have in the field? They have the manpower to assist with that. So kind of fits into the kind of both the maintaining and then, also the budget consideration. So like to think a lot of those things again, beforehand, as far as, picking out what's gonna be the best fit for you. So trying to look and see what's out kind of in the marketplace. And this is probably a really basic list. Your really low cost, the dust deposition gauges. I mean, it's a pretty passive way of monitoring. You basically just, set up a gauge, collect some dust, send it off to a lab and see what you have. Gravimetric sample, kind of similar, using a pump, collecting a physical sample, which sometimes is needed. We need to see exactly what's in the soil maybe that we're digging up, and need to include a lab sample with what we're doing. Really, there's a lot of push towards the direct read, particulate instruments. It makes data collection a lot easier. So really spend probably a little more time walking through some of those here, because that's what we're seeing quite a bit more of out in the field. Mentioned earlier the federal reference method and federal equivalent method. These are the ones that EPA has. EPA approved. Like I said, there's a good list of manufacturers there that have that equipment. What's kind of growing is the near reference field and the near reference monitoring. We certainly fall into that here at TSI. Laser photometers, and then one that's kind of growing is the low-cost sensor market. I don't know if that's going to necessarily replace what needs to be done for perimeter monitoring, but we're seeing a lot more of it for some indicative monitoring, and some higher level monitoring needs to be done after that. It could be part of a program. May not really replace obviously near reference or FRM, but could be part of it in the long run. So federal reference method, they're typically expensive. You're talking probably like 80K instruments. Typically, they have to have a power source. It's permanent sitting. They're not, not really easy to move around. BAMs are probably the big one, and companies like Met1, Sabata have those, which actually, that uses actually collects the dust sample running through the meter. The TOM is the oscillating kind of glass tube, also another method for federal reference, and then some like the high volume air samplers, companies like Tish have those. Again, all highly accurate instruments. Again, they tend to be a little more cumbersome, not as mobile, but they give you really good information. Near reference monitoring, as mentioned before, this is a little more of the world that we live in. Typically, you'll use like laser photometer for monitoring particulates. Dust track obviously is one of the big ones that we make. Air quals guide units, Casella. There's a few others out there. Kind of what I got highlighted here, and many of you probably have rented units similar to that one in the Pelican case there. Next to it's kind of a little more of a newer unit, our environmental dust track, so it was a little more of a redesign. So some of you might have seen that or used that in the past as well. Kind of going briefly into those and some of the differences. The Pelican case version is our desktop photometer, so we can measure up to 4 particulate sizes simultaneously: PM1, 2.5, 4, 10, all at the same time. It gives you some space in there if like you need batteries. You can see kind of in there. There's a bit of a battery setup. Has room for telemetry system for sending data elsewhere. Even have a little space if you need to put other instruments. Obviously, dust being the big one, but say you've got a requirement that you have to do some gases or some VOCs. There is some room in there to do that as well. On the right is kind of like a redesign of what we did with the desktop version. Kind of includes the some of the auto zero capabilities. Filter just basically takes away the screen and makes it a little more compact, putting it in a metal enclosure. And what you can see also there is we do have a gas monitor in there as well, so if you do need, again, if it's needed. And the little blue thing in the center there, that's the Netronics Themis, and what that does is that acts as a data logger or GPS unit modem. So that sends and collects all that data. This is something that RAECO uses as well. It's a really nice system. It allows you to incorporate not just instruments that we make, but a lot of other manufacturers. I had a situation with a customer where they had some RAE units and they wanted to incorporate them with some dust monitoring as well. So able to come up with a solution using that Pelican case there, like you see on the left, and including some instrumentation they have already with the dust track, and send it all to a cloud-based system and get all that information in a single source. So this basically kind of show you the kind of the evolution of how we're changing up our dust track that's in the field. And we do have some some flexibility as far as powering with it. You can kind of see there's kind of lower right hand corner there in the middle case. We can get batteries in there. Both of these do have the option. It's a plug and play solar option. So if you are in a remote area and you need continuous monitoring, that solar solution is really nice. So I did talk earlier as far as, hey, how accurate are these instruments? And some of the the various near reference instruments out there probably have done studies. We have a long history with a lot of different research institutes and universities that have used our equipment and compared them to some of those federal reference method. So if we talked like, hey, is this information be good enough? In a lot of cases, yeah. What can be done with a real-time near reference monitor? Absolutely. What we got here is just kind of how a dust track DRX did compared to a TOM. And you can kind of see the line there. The R squared there is pretty strong, and the correlation is pretty strong there between the two instruments. And kind of did the same thing with an EBAM. Had a little bit of help from the state of California. Ran it side by side, and again, real strong correlation to an EBAM as well. So, so when you go to some of these, agencies may ask, hey, we're here and we have to use EPA, but is near reference good enough? So it's always a question to ask for those that you're ultimately having to provide information to and information for. Touch on briefly, low cost sensors. This is a really growing area. Again, I don't think this is going to take the place of some of the other technologies. I think this is going to be an addition to. Wildfires have been a real big part of way of life here on the West Coast, and a lot of companies are having to adjust. There's some new regulations as far as work activities that can go on with wildfires going on. So businesses are looking for ways. Hey, how can we monitor this without spending a whole lot of money, even if it is just indicative. Others are incorporating this into everyday operation. Whether it's a hospital, whether it's a campus. They kind of want to have an idea, hey, what's going on, air quality, and if we're seeing some spikes on things, and we need to bring on some more accurate data, we can bring some other instruments on site and do that. So these are there's a few of the players that are kind of moving in, and there's more and more entering every day. This is just a few. We make a Blue Sky, Purple Air is probably people very familiar with that. Clarity, AQ Mesh are both pretty good size. Some of the consulting firms are moving into this as well, building their own systems. Like Ramboll's got something, and Golson as well. So it's definitely there's demand for it, and again, that comes back to just awareness, a lot of a community awareness, and we talked about that's one of the reasons that we're doing some of this community monitoring. If we want to talk about actually tracking the data, obviously going right up to an instrument, you can pull the data. You can certainly do that. It's a little more laborious. Run reports and send information on to regulatory agencies. You may have a situation where it's like, hey, we need to know now if something happens, not, hey, let's pull the data for the day, and then something happened at 1 p.m. I guess we should have done something. So certainly seen a growth in this area too, and then the cloud-based solutions. We do a lot of work with Natronic, so I have their example up here. It's a nice system. It does that. We talked about calculating the differential. Software actually does that for you. So if you have a couple monitors, an upwind, downwind, there's things within the software that will calculate that differential. And if you have an alert, so for those in Southern California, that is super helpful because now they know for sure, hey, we had an exceedance, so we need to stop works or we need to take other action because we hit that threshold. But it also it makes it much easier for multiple people to see the information, get at it quickly. So all those different shareholders have that information and they can get to it quickly. The alerts is certainly a big part of it too. I mean, that's one of the big reasons we're monitoring. We want to know now that we have an exceedance, and how do we get that to those quickly and again, so it's just simple as like water truck, or could be some other activities. Yeah, the other one is TSI Link. This is something newer that we've developed for a lot of our low cost sensors, but kind of similar. Provides real-time information, provides historical data as well. But again, with some of those indicative sensors, it's a nice tool to be able to share information pretty easily. And I put the API capabilities on there as well, because both these systems do have that ability where if you need to tie something into like a broader network, I mean, maybe the city, maybe the county, they have a site. If there's activities going on and they want the public to be able to see it, you can tie the information that you're collecting here onto those websites, and just make sharing that information much more transparent, to those either other agencies or to the community. So again, there's more and more of these coming onto the market right now. So there's a lot to sort through if you're looking for a solution here. So here I just have kind of hey, here's a potential just kind of basic site setup. We may just have 2 monitors here. We have one that we set on the corner of the property, one on the other corner of the property. Maybe we have some prevailing winds that's going from east to west there. But we have 2 units. They're exactly the same. Similar model, settings, calibration, all those correction factors are identical. And then if we have that system in place that can do that differential, we know, hey, this is our dust, this is our mess, this is not from an outside source. Had another customer kind of similar to this where they have they were really concerned about a neighbor with the process they had. I think it was like a gypsum mine, and what was happening is they were noticing their like intakes were filling up a lot more than usual. And so they were trying to do is kind of, hey, we're going to put this on our perimeter and kind of show, hey, we think a lot of this, this gypsum dust is coming from your process, and we're going to identify that and share that with you. So while a lot of times we're doing the perimeter auditing for the for what we're doing ourselves, sometimes it comes into play with what others are doing, and we want to see how that might affect what we're doing at our facility. So a couple projects here. First one, probably a lot of you watched the Super Bowl a few weeks ago. Did some work, Citadel, the links there that kind of talks a little more detail about the project itself. But they used our dust track solution, the DRX version, kind of that Pelican case setup, and use that with the Netronic system, gave them real-time communication. They had to set up alerts as this was in Southern California. Yeah, because as you can see just from the picture, there's not exactly a lot of availability for power. So they used a solar power solution for that, which can be very, very helpful. Certainly on the West Coast, we have a lot more sunshine than other parts of the country, so that's always a good solution. But those continue even in those environments. That solar power system will charge up a battery and run the unit for an extended period of time. Another project up in Alaska, a little further out. I know I got a little West Coast biased here, so I got a little West Coast projects here. Up in Juneau, Alaska, they had some concerns about their activity and whether it was going to get into nearby creeks. So it was almost more of an environmental concern. So they used a number of DT units as well. That's our environmental unit, that kind of metal enclosure that showed earlier. And by providing that, they were able to provide information both to the the city, community at large, and as well as the regulators who were real concerned about making sure a lot of that was not ending up into the local ecosystem. A little quicker than I thought maybe I would, but just briefly, TSI, if you don't know who we are, we're known for making particle and flow instruments. With long established history for doing that. Pretty well known in industrial hygiene and academic world. Got a long list of instruments there that you may or may not be familiar with. So we certainly have a history in working in a lot of different industries, including those outside of health and safety. Actually, a number of these things, especially like our energy and comfort line, the kind of testing and balancing equipment. I know RAECO Rents carries a lot of those as well. And we have a worldwide presence. Again, if you don't know TSI, and that's okay. Our main manufacturing headquarters is in the Twin Cities area, but we have offices and support all across the globe. So if you have projects even internationally, are planning those internationally, we can help support those for you. So that being said, with a very short 30-second commercial there, might have some questions.
Yeah, Tom, I had a couple that have come up. Is
Yeah.
perimeter dust monitoring required for controlled burns like agriculture fields? Heard anything about that?
Ooh, you know what? I'm not aware of that offhand. There are some control burns. I think California has some regs. Whether EPA has something in place, I would guess that they do. In other states, not sure. That's probably something to check though with local either EPA office or maybe even like air quality. If your state has a air quality board or air quality department, that'd probably be something to check with them. I would imagine you may have there's probably some things that you do have to put in place, but whether you have to do active monitoring, no, that's a good question. I don't know that offhand.
Okay. Any recent results regarding respirable crystalline silica dust levels during fracking operations on oil and gas completion sites?
Well, I think if the question's about the reg, I think that's going into across all industries, I believe this summer. Typically for silica, it's individual monitoring. So you're going to want to measure on an individual. I have had inquiries where somebody may want to monitor on a site to kind of get a general idea near a certain process to see what kind of silica exposure there is. But ultimately, if it relates to the individual, you should be monitoring, whether putting a pump on an individual, because you do have to have a weighted sample that can go into determine the compliance. We do have some real-time instruments can be used in conjunction with that, so you don't have to do active sampling. So if you do take some gravimetric samples, you can still use some like real-time instruments, basically kind of confirm that maybe if you put some engineering controls in place, whether those are working, or if you have a lot of active monitoring. So hopefully that answers the question there. But I know that it's been kind of a phased in. It's hit some industries at a time, but I believe it's this summer that all industries will be affected by that new silica rule.
Okay. When integrating data, consideration should be given to the averaging period. Many alarm triggers are on a 10 or 15-minute rolling average. Can equipment accommodate the rolling average in real time, or do you always have to wait until the next data log to find the alarm? Potential to miss an alarm trigger.
Yeah, no, that's a good question. A lot of the solutions that we have with with both the the Natronic solution, it's collecting data every second, and you can choose that averaging. Might be reporting once a minute, but it's going to report a lot faster than a rolling 15-minute average. So that's certainly one of the benefits of using a a near reference real-time instrument, because you're gonna know sooner than 15 minutes after an event. Event hits, you're gonna know moments after that.
Okay. Next one is, the world is changing how we do business and gaining access more data quickly. What are TSI's efforts to advance sensor technologies for remote control monitoring to provide short and long-term data to the contractor, especially in urban areas?
And that's probably what's fallen in a little of the low-cost sensor market. That's really a big benefit of the low-cost sensor. I mean, you got maybe $400 for a sensor, so you can place a lot of different data points, collect that information quickly, share it easily. So there's a lot of, as I mentioned earlier, there's a lot of demand in that area. There again, it just comes from like the question said, there's much more awareness about it. So yeah, we've certainly put some resources to help fill that area so that you can continue to monitor year round without without maybe having to have, larger, maybe more expensive instrumentation in place. So we're doing that both, outdoor space, indoor space, try to get that information on, a single platform, and make that information and that data easy to share. We'll have mentioned a little about gas. I mean, obviously we're focusing on dust primarily, but sometimes that gas aspect, whether it's VOCs or other pollutants, that's something that we're working, and we'll probably have something out here shortly that even the low cost world will be able to handle particulate plus gases as well. So if that's something that you have interest in, we can certainly talk further about that. Almost probably could be a whole presentation just in the world of low cost sensors itself.
Okay, how much does the TSI environmental redesign weigh? You also said there is no screen, so is there any way for users to get a real-time measure if they wanted?
Sure. The weight of it offhand, oh boy, I probably should have a stat sheet nearby, but weights, I mean, with the BMS, it's a little bit more than the Pelican case. But putting it on a tripod's not an issue. Doing a pole mount. The redesign was really put into place to incorporate the Netronics and that real-time cloud-based solution. Rather than having to physically go up to an instrument and pull data and see what's going on, it's you use that system to observe, on your computer, on your phone. So you'll always see that data presented to you without having to go out to the site, open the box, and read what's in there. We do have the capability. There's an input on the side, so if you wanted to, walk up with a laptop and pull some data from the instrument itself, if that's the way you choose to see your data. But as far as seeing it real time, it was really designed with the cloud-based system in mind.
Okay, I think this is in regard to the DustTrack DRX. How many parameters will it measure?
It's doing 4, so it's doing PM1, 2.5, 4, and 10 simultaneously, and 4 is respirable.
Okay. Let's see, got some more here.
I guess I should mention that too. I'm like, if your project, because there's some projects that only require PM10. So while the DRX does 4, our dust track, we do have a version that'll just measure. You can put an impactor on it, do PM10, do just PM 2.5. So that's, I guess, one of those parameters that might vary from project to project. So probably glossed over that a little bit earlier.
What's the difference between the 8530 versus the 8533 model for the dust track?
Somebody might be on the website. That's primarily the difference between measuring in a single size fraction and measuring all 4 simultaneously. So that 8530 is what's called our dust track 2. And that measure, you can put an impactor on it for measuring either PM1, 2.5, 4, or 10. The 33 version measures all 4 simultaneously.
This one is for the Juneau, Alaska project. How do you use PM concentrations from the dust track to inform deposition effects on the creek?
So it's not going to necessarily say what the issues with the creek. What they were concerned with is that there was going to be enough concentration that was going to flow. So as far as like, if they had rainfall or whatever of that flowing into it, it's not going to monitor for that. But basically stuff that goes airborne to make sure those concentration levels were at an acceptable level, and so that they needed to knock those down with a water truck. That's what they were doing. So it was really, it was really about the just the particulate itself.
Next one is, can you provide some general information on the most common PM10 and 2.5 construction site standards?
the most standard as far as like, I guess, concentration levels that might be required.
Yeah, or when you would,
I think
when your alarms would be set to, maybe?
that might be, yeah, and
Probably varies by,
yeah, that's it. Excuse me, to say what like, yeah, is most standard, I think it really does vary from local agency to local agency as far as what is allowed, and that would probably be something to check with a local um, either advisory board or local environmental or even public health as far as what their requirements would be for what to set that at, because that would probably be tough to say generally.
yeah. Can the TSI handheld unit be used for required perimeter monitoring? I would say it wasn't designed for that.
Yeah, that's probably fair. I mean, that's really more of a like it's a surveying tool. It's really what it's designed for, as opposed to like set it and leave it, which is kind of more that either the desktop or the environmental unit. You just probably wouldn't be able to get a long enough sample reading. You just basically when you're out there. And
Yeah,
again,
that
for powering and things like that. Yeah, powering and things like that would just
battery is probably 4 or 5 hours maybe, and
with the
versus,
on the battery. That's kind of it. So it probably not the ideal instrument for that.
I know OSHA requires gravimetric sampling for compliance with their recent crystalline silica standard. Any thoughts on tech solutions to at least do some screening?
Yeah, you could always do some like preliminary. One of the things with the dust track is you can set something on that does have the ability to put in a filter cassette and take filter media. So you could put a 37 millimeter cassette in that desktop version. So if you wanted to kind of measure in real time for a bit and then have a sample, like an area sample, that's something you could set up with a lab to send you that filter, put that in the dust track, kind of get some preliminary of what's kind of going in the area. And where that'll help you out too is it may help give you that composition of silica that's in the in the area, so that if you move on to personal sampling, which you may ultimately have to do either yourself or have a consulting firm come in to help out. You might have that, it'll give you a little insight on like how much silica you have there currently. It may also help to, it would help you incorporate if you wanted to include, some real-time instruments. Because with the dust track, we do have the ability to do some custom correction factors. So silica, for example, if we know the percentage of silica that's in a sample, we can build a correction factor and give you some real-time solutions. And again, for the compliance, you do have to have a gravimetric sample. So again, with the real time, it doesn't take the place of it. It basically helps support the program you could have in place. So it'll allow you to do a lot more monitoring without being reliant on a lab to get results back to you a couple of weeks later. But I get, and it kind of almost leads into how much if we're doing a project. Should we be putting instrumentation beforehand, kind of before and after? Because I see that a lot, where somebody may put out some instrumentation before they even do any kind of digging activity. Like, hey, let's see what it's like before we're even doing anything. It's not uncommon for people, set up instruments for like a week, sometimes longer, to kind of set a baseline of, hey, here's what we've got before we even start our project. And that way we know if we see spikes at certain times of the day, is that from an activity or is that something that might be naturally occurring. So that kind of, I guess, falls in that a little bit. So it's kind of doing that preliminary monitoring, and then same thing with silica. I mean, you could get kind of like a baseline of what's going on near a certain activity, and then do some things after that.
Supply chain question for you. What's the lead time on the purchase of 4 to 6 dust track environmental or desktop DRX instruments from TSI?
I think we are somewhere, but then it changes. I think we're somewhere between about 2 or 4 weeks, I think, right now, for depending on some different powering options and things like that. If that's something you can always email me here that's on there, and I can put you in touch with the right representative in the right part of the country here, and help you with that conversation if if you have a project coming up soon and you're thinking about adding some units to your fleet.
Okay, next one is the TSI side pack still manufactured? Yes, it is. We've got the TSI 5 side pack 520 now, right?
Yep, and comes in two versions. We've got the standard version, and we also have one that has an intrinsic safety rating on it. So, yeah, so places like some mines, oil and gas, anywhere where your instrumentation requires that, we've got an instrument for that. And I believe you have both of those, don't you, Matt?
Yes. Yeah, we've got both the 520s now, intrinsically safe and non.
Perfect.
What procedures should be taken if the VOC readings on a Mini Ray 3000 on a site are too high? For example, above 15 or 20 parts per million.
That's probably a better question for the good people at Honeywell.
Yeah.
That might just be like a limit on the sensor that exists. If it's VOC, I mean, I guess it's, I guess depending on typically it's like a 10.6 lamp. I don't know if the lamp you're using is different if you're using like benzene specific lamp or, but usually the ranges on those are pretty good. So that might be a question to handle offline.
Yeah. What is the radius that the optical particle sensors can see?
So there is a pump in the unit. It's pulling about 3 liters a minute. So I mean, it's pulling in air, but it's not gonna, I guess, set a radius of 50 feet. What the minimum radius, that's probably tough to tell, because that's going to vary. If you have it sitting outdoors, if you have wind and things like that. I mean, it's catching what's nearby. How far is nearby? Probably don't have a great answer, because that probably varies. So maybe not the answer you're looking for. But it's, if you have it set and sitting 10, 20 feet away, you're probably not catching everything that may be going by. So a lot of that pretty much has to pass pretty close, I would say, to the monitor itself.
And Randy with RAECO Rents says the Dust Track Environmental is 30 pounds. So
thank you, Randy.
That answer. Are there any limitations with TSI equipment and airborne asbestos?
Asbestos is not a world that we play in. And we can't, with a laser photometer, that's a, I guess, limitation, that it can't tell you what the, what is actually floating. I guess that's kind of where it comes into, taking gravimetric samples, whether part of that'll be asbestos. Might be a question for lab, whether that be collected. So, but yeah, usually asbestos is not. I guess because the short answer is yes, it would. I guess it would see, but it couldn't tell you like you've got X percent of asbestos. I think you'd have to still have to have a sample of that as a component. So it's probably a long way to or long answer for a long short question.
All right, somebody's asking if there's a conversion of particle count to mass for building dust.
So that's kind of what the dust track's doing, is giving is mass concentration. If you're talking specific, like you need to know particle counts, that's something different. I mean, that's a little more like the AeroTrack line. So if you're trying to get different buckets of particle counts, that's going to be like an AeroTrack, or even like a P-track for ultrafines. But the dust track is taking mass measurements for you. So hopefully that answers that.
Someone's asking if we offer insurance in the event that the units are relocated. Yeah, we can add a damage waiver that would help in that event. Otherwise, we typically look to your insurer or our insurer to look to reclaim that. FYI, RE Silica, if strictly following OSHA Table 1, then exposure monitoring not required. Okay, it's just a add there
That's
to
it.
that. Let's see, what else we got here? Every time I click, it scrolls all the way back to the top. What sort of impact does pouring rain have on equipment performance besides knocking down the dust?
That's probably the biggest thing. Most of the instruments have have an inlet to stop rain from getting into the instrument. The other, and then maybe the other part of that question might be humidity, because humidity can cause a spike or a false reading, if you will, or a false spike. So most of our instruments, we have a drying system in it. So it'll actually dry the air before the sample goes through the unit itself and corrects that. So that in our, it's a separate piece that'll set, if you're using like the Pelican case version, that heated inlet will be part of that. It's integrated with the inlet. That heated inlet's actually integrated with the inlet on top of the dust track, the environmental version. So yeah, that could be a consideration too. So that's something that we compensate for.
Okay, that answers the other question about interference humidity. So that answers all the questions. Well, thank you, Tom, for the presentation. If there's any other specific application questions, feel free to call me at 866-RENT-EHS or 866-736-8347. You can also reach me by email at matt@raecorents.com. If you want to know more about the technologies we supply, please follow us on social media. We put out lots of good technical tips on our blog and on our website in the training area. We do record all these sessions, which you'll find on YouTube and on our website. If there are topics you'd like us to cover in our webinars, please send me an email with the subject to matt@raecorents.com. At this point, there are no further questions. Our presentation will conclude. Thank you all for attending, and thank you again, Tom. Appreciate it.
Absolutely. Appreciate it. Thanks.
Bye now.